Why always in your class only few students are answering? Very few. I can say hardly one or two. What about others? Okay, Aishwarya Shetty. What do you know about a device controller? Aishwarya Shetty.
Yes, ma'am.
What is device controller? You no need to exactly define. Just
Ma'am,
what you
it's a
know about
software.
device controller is a software.
Yes, ma'am.
Oh my God. Is device controller is a software or hardware?
Ma'am, device driver is a software and device controller is an hardware.
I asked device controller. Okay, device controller is a hardware.
Ma'am, it accept command from operating system and execute it.
Fine. Device controller will have any registers, any memory? Aishwarya?
Yes, ma'am.
Does device controller have any memory? Yes or no? You know the answer or you don't know?
Don't know, ma'am.
Okay. Ajil,
Yes, ma'am.
will device controller have a memory?
Yes, ma'am. It has memory.
Okay, it has memory.
Yeah.
What is device driver, Ajil? Yes, Ajil, what is device driver?
Software which is used
Which is used
to control hardware.
to control which hardware?
Like controllers and all, like touchpads.
So device driver is a software which controls controller, device controller.
Yeah.
Okay. Hello. Yes. Okay. Neha. Neha, are you there?
Yes, ma'am.
Okay.
Hello, ma'am.
Neha, what do you remember about the hard disk? Hard disk drive. We discuss about hard disk drive, right?
Yes, ma'am. Ma'am, it is used for storage.
Okay.
Of data.
Okay. So hard disk, can we say hard disk is RAM? Random access memory?
No, ma'am. It's read-only memory.
Okay. Anything else? How it looks and how the data will be stored? What are the mechanical devices are there in it?
Ma'am, it consists of number of platters.
Okay. Okay, each and every platter is divided into what? Shweta? Shweta, are you there?
Yes, ma'am.
Yes, Shweta. Shweta, device driver is device specific or it's a controller specific? Did you understand my question? So device controller manufacturer will manufacture device driver for every device.
No, ma'am.
Then the device controller, device driver is specific to what? Suppose there is a scanner. Okay. For the scanner, always single device driver can be used. Can we use single device driver?
Yes. Yes, ma'am.
Hello. Archana, I think when I called you were in lecture. Sorry, I want to say something that I have kept my mark sheet, no IoT mark sheet in the college. So that should be given to Vaibhav. That's why I called. But that I said to Shruti because right now Shruti is at college. Okay, 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 okay. Chalo, bye. Yes. Shweta,
Yes, ma'am.
there is a scanner. The scanner manufacturer will have only one device driver software for the scanner,
Yes,
or
ma'am.
he has to. Yes. Okay. Supreet,
Yes, ma'am.
device driver is specific to what? As I asked before, there is a scanner, then it will be only one device driver for that scanner, or it differs. It differs driver
मैम
to driver. Yes.
मैम डिफर करता है,
Sorry.
डिफर करता रहेगा मैम, जैसे
Okay, it will
स्कैनर
differ.
के लिए हाँ मैम.
For example, why? How you are saying it will differ?
मैम हर एक जो भी कंप्यूटर में पार्ट होता है उसके अलग अलग ड्राइवर रहता है, जैसे कि ब्लूटूथ ले लो, वाईफाई के लिए भी ड्राइवर जरूरी होता है, स्कैनर के लिए भी एक चीज होता है ड्राइवर.
Is this the device driver and operating system has any relationship?
मैम what?
Device driver software and operating system has any relationship?
हाँ मैम, डिवाइस ड्राइवर जो है मतलब हेल्प करता है ना मैम उसको डेटा लेके जाने में.
Okay. So device driver will help to carry the data to operating system, right?
Yes मैम.
Is this correct?
मतलब मैम मतलब इंटरेक्ट करने में इजी मतलब यूज होता है उसका असल में. जैसे मुझे समझो अभी ब्लूटूथ से कनेक्ट करना है, तो एक बीच में ड्राइवर होना चाहिए तभी जाके मैम मतलब दोनों मतलब मुझे
That's okay. Driver should be there. Driver should be there. My question is different. The driver will vary controller to controller, or based on something else it will vary. And that's my question. Okay, let us see anybody else is giving answer or not. Ashtalakshmi.
Yes, ma'am.
Ashtalakshmi.
Ma'am, if we want to connect any peripheral to our device, then that particular thing will have a inbuilt controller, which is a device controller, which is a hardware, and device driver is a software which is present in the operating system.
Okay. So suppose there is a plotter or any other device, scanner. For that scanner, particular specification, the scanner which has a particular specification, for that scanner, always if you use the scanner in any of the system, you will use the same device driver or it will differ. Device driver will vary depending on what? Will it differ system to system, system architecture to architecture, or operating system to operating system, or controller to controller, or type of the driver to driver? What? Based on what the device driver will differ. Danya,
Yes, ma'am.
you are buying a scanner, okay? So for that scanner, always the device driver software will be the same or it will differ. So nobody is listening the lecture properly, isn't it? Attentively or not attending the lecture, isn't it? That's why you couldn't answer. See, if we buy driver, if we buy any device driver, of course, we will not buy device driver. If we buy any device, along with that, the device driver will be given. Okay. So that will differ operating system to operating system. Manufacturer should create a different device driver for that particular device, depending on the operating system. Okay. A particular scanner, when you use in Windows 2000, the device driver will differ from the same scanner when you're using in Windows XP or Windows Vista or any other Linux operating system. So operating system to operating system, the device driver will differ for same device. Scanner, a particular scanner is that is a single device. In that scanner, when you use in Windows 2000, you have to use one device driver, but the same device driver you can't use in Windows XP when you use the same scanner. Remember, so operating system to operating system, the device driver will differ. So the manufacturer of a particular device, IO device, has to create the device driver for each and every operating system, each and every version of the operating system. Okay, so that is very important. Okay, how the device driver will be added in the operating system? I said there are three ways. Any one of the three ways, the device driver will be usually added in the kernel of the operating system. Can any one of you say the three ways? There are three ways, three different ways. Device driver will be added inside the kernel of the operating system. Who can say the three ways?
Creating reeling, making entries on the fly.
Yes, correct. Okay. Okay. Students, we were seeing about the IO devices with respect to operating system. Okay. The input output device, we can say input output device management, or we can say input output device communication. Okay. Device communication or device management. Now, this device communication or device management can be done again 3 ways. Okay. Device driver, wait. Now, I showed this picture already. CPU, memory, these are the devices which are connected currently with the particular system. Okay. Here we have CPU, memory, and display unit, and a keyboard as a input device, and we have a hard disk, external memory. We can say this is a secondary memory also. Okay. All these are connected with a bus. Okay, so all these can communicate. Okay. So now the CPU will communicate with the IO devices. CPU will communicate with IO devices. Why? Because CPU only will execute the program, right? It's a user defined program, or if it is an operating system program, any program will be executed by CPU only, by no other devices. Okay. So when CPU execute the program, it has to know, when it is reading the program, it will know that when the data should be read from input device, when it has to go to output device. So the IO operation, we can also call read write operation, will be initiated by the CPU. Why? Because CPU only is executing program. In the program only you will write what input output statements. Okay. So when input statement, or we have to say the input instruction or output instruction is getting executed, that time CPU should initiate the IO operation. Okay. Input or output operation. Okay. Input output operations are nothing but reading from a device and writing into device. Reading from device, writing into device. This is called the input output operation. Okay. So CPU will initiate by giving the address of the device and also the location, memory location in the device, by sending through the bus. Okay. So by looking to the corresponding address, the device will find, okay, actually device driver, device controller We'll find that, okay, communication is going to happen with me. So if the controller or the particular device is free, that should send acknowledgement to CPU saying that yes, we can communicate. Okay, these are signals. Okay, so like this only communication will happen. So the CPU can communicate with input output devices by following any one of the three methods. Any one of the three methods. That is only we are going to see. Now this we can put a title as, for this we can put a title as CPU or processor. Processor IO device communication or IO management. IO management. Okay, both denote same. When I ask the question, explain CPU and IO communication, you have to explain these three ways only. Or I can put the question in another way, explain the IO management. Okay. So that time also you have to write about IO communications, processor and IO communication only. Is this clear, students? There are two ways the question can be asked. Okay, but answer is same. Okay. Okay. Now we will see what are those three ways. Okay. 1 second. I have that. I just say share roughly drawn image in the paint application. Okay. So IO device management or IO and CPU communication can be done using any one of the three ways: programmed IO, interrupt driven IO, or DMA, direct memory access. Okay. Uh, programmed IO, interrupt driven IO, DMA. We can call, if suppose the processor and IO communicated by following programmed IO method, we can say the IO as a programmed IO. Okay. If it follow, the communication happens by following interrupt driven way, then we can call that as a interrupt driven IO. Okay. Or otherwise we can say that the IO devices and the processor will communicate by following direct memory access method. Okay. So any one of the three ways. This diagram says only the first one, programmed IO. Programmed IO. In programmed IO, there is a CPU because communication is happening between the CPU and IO devices. Student screen is visible, no? Just don't mind about the drawing, the way how I have drawn. Okay, you have to understand, that's it. Okay, CPU and IO devices both should communicate. You know why it has to communicate? Why it has to communicate? Because input output operation should be done. Okay, so read and write operation, read or write operation is called what? The communication between the CPU and IO device. Okay, so in the interrupt driven IO, there is a CPU, there are IO devices. In between, we have a interface called the IO interface. Okay, in this IO interface only, we discuss about the device controller, no? Device controller that will be there. Okay, between the IO interface and IO devices, we have operating system also. Okay, so when it is operating system, you can imagine inside the operating system, there is a device driver also. Okay, students, please listen. CPU and IO devices. Why plural? Because there may be more than one number of input devices and output devices can be connected. Even in normal situation also, in our laptop, we are connecting the mouse and also keyboard. Okay, so there will be a more than one number of input output devices. Okay, so how the CPU and the IO devices will communicate, will perform read write operation. Okay, there is an interface which is called, between CPU and IO devices, there is an interface which is called the IO interface. Inside the IO interface, you can imagine there are many other hardware components along with the device controller. When I'm saying device controller, don't confuse. It is a hardware. Hardware. Put in your mind. Hardware. Device controller is a hardware. Okay. And we have IO devices. So the CPU will not be directly connected with the IO devices. In between, there is an interface. Okay. If you expand the interface, there will be a different configuration. One of the configuration I have put here. Okay. So don't think that always the IO interface will have only these components. Okay. This is a one set of configuration. Okay. So inside I just expanded the IO interface. Inside the IO interface, address decoder is there. In register, out register, command register, signal registers. All these are registers. Okay. So we have address decoder, we have in register, out register, CMD, command. Okay, CMD register, signal register. We can call the signal register as control register also. This is command, this is control. Okay. Now what will happen in programmed IO when the CPU and IO device communicate? I did not say about the buses. These are, see, in the previous diagram, when I showed in the PPT, that they have shown a single bus, but actually that is not the single bus. There will be 3 different buses: address bus, control bus, data bus. Okay. These buses are nothing but wires, communication channels, cables. Okay. If the CPU want to send address, it has to send through the address bus. Okay. Address bus is a unidirectional bus. Address bus is a unidirectional bus, which means always the direction, the arrow, the communication will go from CPU to the other device. Okay. So address bus is a single directional bus. You can put arrow like this. You can't put arrow like this because address will not come from any other device to CPU. Remember, always the CPU will create an address and it will send it to device. Okay, so it is a single directional, which is called unidirectional. Okay, so address bus is a unidirectional bus. Okay, control bus will carry the signals. Here also I said, you remember, signal register, which is also called a control register. Okay, here I put a control bus. Okay, the control bus can also be called a signal bus because control bus always carries the signals. What signals? For example, CPU wants to do input operation or output operation, read operation or write operation. Okay, that is one of the signals which will be sent through the control bus. Okay, there are many other signals. That is out of scope for this concept. Okay, we are not going to discuss about that, but you should know. You should not think, okay, using the control bus only the read signal or write signal will be sent. No, there are other signals also, but we are now interested with only read and write signal. Okay. So the read or write operation should be performed. That signal should be sent through this control bus. Data bus will carry the data. For example, a CPU is sending some data, one word file to printer. Okay. So that time from the CPU, the data should go to output device, which is our printer. Okay. During the read operation, CPU will request some data from the input device. The device will give the data to CPU. So this data bus is bidirectional. Even the control bus is also bidirectional. Except the address bus, these two buses are bidirectional, both the directional. CPU will also use control bus to send the signal, and other devices can also send the control signal to CPU. Okay, same like the data bus. Through the data bus, CPU can send the data to other devices. Other devices can also place the data through the data bus to the CPU. Is this clear, students? I hope you all are okay. So that's why we have
Yes,
three
ma'am.
different buses. So these 3 different buses will be connected with the CPU. Actually, here they did not show the memory. We have a memory here also. Okay, our RAM. When I'm saying simply memory, always remember that is a RAM. Okay. Now, what we are going to see, communication, CPU and IO device communication. Okay. Assume that there is a read operation. Okay. initiated by CPU. When the read operation will be initiated by the CPU, there is a program which is getting executed. In that, one of the statement is a input statement. So that time CPU will create the read signal. Okay. So the read signal will send through the control line. Okay. And address of the read data. That means the address will have from which input device, because here when you see there are assume more than one number of input devices right now connected. Okay. So if from which input device it wants to read the data. Okay. That address of the device. And also after found a particular device, inside that device there is a memory. In that, from which memory location it has to read the data. So that both address will be sent through the address bus by the CPU. What are the addresses? Address of the device and address of the location of the data. Address of the location of the data that will be sent by the CPU. CPU will create this. Okay. So this you will study later, how the CPU will create an address. Okay. So CPU will create the address. We assume that read operation, okay, is going to happen. So read signal will be sent. At that time, data bus will be free only because there is no data right now. The CPU should send. Okay. Actually, during the read operation, CPU should receive the data. It will not send the data. Okay. Okay. So in the read operation, address and control, both bus will be used by the CPU to send the read operation and also address of the IO device. Now that will come to IO interface. Okay. In IO interface, we have address decoder. The address decoder will decode and find exactly in which device the CPU wants to communicate. Okay. There is a address translation will happen here. Okay. That we will study later. Okay. CPU will send one address. Exactly that address cannot be used by the IO interface. That address should be converted to some other address. Okay. So that is called address decoding. Okay. So how this process will happen, that we will be discussing in later chapters in operating system. Okay. So the address decoder will decode the address which is received by the CPU, and now the decoder will find exactly the device address and the location, data location. Okay. Now the CPU plays the address and the signal in this programmed IO. After placing this read or write operation, the CPU will not be free. CPU, after placed this, the CPU will keep on look at the CMD register, command register, because now the CPU has given the work to IO interface. Now IO interface has do the work and it has to submit the work to the CPU. Okay. So after upon completing the IO operation, the IO interface by the IO interface will reset the CMD, command register. Okay, saying that yes, I completed the work. Okay, that's why the CPUs keep on polling into the CMD register. Okay, so CPU will send the address and control, and then CPU is not free. CPU should start the polling. Polling means whether the task has completed or not. That should be seen by looking into the CMD register. Okay. So in between, the CPU will start the polling. It will keep on poll the CMD register. Okay. What the IO interface will do, it received the address and it decoded the address, and it will see whether the IO device in which the CPU wants to communicate, that is free or not. If it is free, it will start the operation. Our operation is read operation. So as per the address, decoded address, inside that input device, we will find the data, input data, which should be read. Okay. That will be read and put inside the in register. Okay. once the IO interface put the data in the in register during the read operation, the CMD will be reset. Okay. That means CMD register, if the CMD register reset, that will tell to the CPU that yes, your operation has completed. So CPU is what it is doing. It is on busy wait. It is keep on looking at the CMD register. Once the CMD register reset, it will know that yes, the data reached to, because it knows the read operation it is performing. So it will look inside the in register and it will take the data and put it in the data bus. Okay, getting it? That through the data bus, it will go to CPU. CPU will put that data in the memory, main memory. Remember. Okay. So this is a read operation. During the write operation, what will happen? CPU will send the address from where it has CPU will send the address of the output device and also location of the output device, and it will send the control register in this control bus may it will send the operation is write operation, so it will send the write signal in the through the control bus, and then the data here, as it is a write operation, the data should also be sent by the CPU. So the data which should be printed or which should be displayed by the monitor, that will placed on the data bus. All the bus will be free. Sorry, all the buses will be occupied during the write operation. Okay. So again, that will reach to our IO interface. Inside the IO interface, we have address decoder. Address decoder will decode the received address and it will find which output device exactly the CPU wants to place the data. Okay. After found that, it will see whether the output device is free, and after it founds it, the output device is free, it will place this data in the location specified by the CPU. Okay, in the output device. Okay, so this is a write operation. Upon completing this work, the IO interface will reset the CMD register. By the time the CPU will keep on do the polling on the IO interface, once it reset, it will look into the out register. Okay, the CPU will see the out register to confirm whether all the data went to the printer or output device, any other output device, and then CPU will resume. Okay, so this is the way the IO operation will be done by following programmed IO method. Okay, programmed IO method. What is a very big drawback, disadvantage, limitation in this communication is CPU will spend maximum of the time for IO operation, because CPU will say that IO device, IO to IO interface, what it has to do. But after saying this, also the CPU should keep on poll the IO interface. Okay. So CPU cannot use its time for other tasks. Apart from IO operation, CPU has to do many other tasks that cannot be done. So this will degrade the speed of the processor. Okay, because other processes which want to execute the CPU should wait when the CPU is doing the IO operation, IO process, because CPU should place the order and then it should keep on poll the CMD register. Okay, so this is a very big drawback in the programmed IO. Because of this, the processor speed will be always what? Very slow. Okay, is this clear, students?
Yes, ma'am.
Okay, next
Yes,
we will
ma'am.
see the interrupt driven IO, which is the second method. Wait.
Ma'am, you're on mute.
Okay, sorry. Okay, students, now the time is over. I have next lecture. So I will finish here the interrupt driven IO and direct memory access. Direct memory access, these two we will discuss during the next lecture. Okay. We discuss only about the programmed IO. Okay. So next lecture, when you come, I will ask the questions from this. So you have to remember. When I was asking the question, I saw only 61 students were there, now 71. So the 10 students joined late. Students, next lecture, you are making me to enable the lobby option. Then only first 10 minutes you can join for the lecture, and after that you cannot join. So please be on time for lectures. Okay. Okay. Programmed IO, you have to go through and come. Okay. Thank you. You all can leave.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.
You're welcome, students. Bye. Bye. Bye.